Assalamu alaikum. In this lecture we will see how to calculate the area under plasma concentration versus time curve using Microsoft Excel. You are given the plasma concentration versus time data in columns A and B. Let's first plot the plasma concentration versus time data as explained in the previous lecture. Insert from chart, other, scatter, then scatter with straight lines. Select the new chart from the chart tools design tab, select data, add new data series, name it, select the X values, then select the Y values. Okay. The plasma concentration versus time data were plotted. To calculate the area under the curve, we will assume that the curve consists of a number of trapezoids. We will calculate the area of each trapezoid. The sum of these areas is the area under the curve. As explained in the lecture, we assume that the curve or the area under the curve consists of a number of trapezoids. The area of the first trapezoid equal the concentration at point 0 plus concentration at point 1 divided by 2. So the average of the two concentrations multiplied by T1 minus T0. So this will be the area of the first trapezoid. Let us calculate it using Excel. Area. The unit of the area is the unit of plasma concentration multiplied by the unit of time. Microgram hour per milli. So we will start from the second row. So the area of the first trapezoid equals, open a bracket, the concentration at 0 time, the cell B3, plus the concentration at the first point, the cell B4, close the bracket, divided by 2, and then multiplied by, open a bracket, the time T1 minus the time T0, close the bracket, enter. This is the area of the first trapezoid. One need not repeat the equation for each cell. We can just copy this cell and paste it for the following cell, and Excel automatically calculate the area of each corresponding trapezoid. So these areas are the areas under the curve for the part of the curve ending with the last point. The last point. To calculate the area of the part following this last, as explained in the lecture, the area of the part following the last point equals the concentration, the last observed concentration, divided by the elimination rate constant. So we need the elimination rate constant. You may be given the elimination rate constant, or you can calculate it from the plasma concentration versus time data. For this purpose, you need first to calculate log plasma concentration. So log plasma concentration, this cells. So we insert equation as shown in the last lecture, equals log 10, open a bracket, select the value for which you would like to calculate the log, and then press enter. You can copy this equation for the following cells as shown earlier. Now we will calculate the slope of the log plasma concentration versus time line. We insert the equation slope, open a bracket, select y values, log plasma concentration values, select x values, time values. This is the slope. The elimination rate constant equals slope multiplied by minus 2.303, and the unit of the elimination rate constant is the unit of time to the power minus 1. Now we will calculate the area under the curve for the part following the last collected data point. This part, the area of this part, equals the last observed concentration divided by the elimination rate constant. So area of the last part equals the last plasma concentration point divided by the elimination rate constant, and the unit is microgram hour per milliliter. Now we calculate the area under the curve. The area under the curve is the sum of all these areas, the areas of the trapezoids, added to the area of this last part. Now we will use a new equation, the equation sum, and then open a bracket and select this range of cells, close the bracket. This will give us the sum of all these areas, and then we add the area of the last part, D18, the cell D18. This is the area under the curve. The unit is microgram hour per milli. The volume of distribution, the apparent volume of distribution, can be calculated using this equation, the dose divided by K AUC. We will use this new equation to calculate the volume of distribution. We need first to have the dose. So the dose was 1000 milligram. The volume of distribution equals the dose. The dose is in milligrams, so we should convert it to micrograms because the mass part of the plasma concentration unit is in microgram. So we multiply it by 1000. That's the dose, divided by the elimination rate constant, the cell D17, and then insert a division sign again and divided by AUC. This is the volume of distribution, and it has the unit of the volume part of the plasma concentration, so milliliter. If we would like to calculate it in liters, we should divide this value by 1000. This is the volume of distribution in liters. We can calculate it, we can compare this value to the value we calculated in the last lecture. We will find that the two values are almost identical. So the two methods give the same values. Now we calculate clearance. Clearance equals the dose divided by the AUC. So the dose equal dose. To convert it to microgram, we should multiply it by 1000 and then divide it by the area under the curve. And the unit of clearance is milliliter per hour. To convert it to liters per hour, we should divide it by 1000. This value divided by 1000. If you compare this clearance value with the value we calculated in the last lecture, you will find that the two values are almost identical. The two methods provide the same values. In this lecture, we have seen how to calculate the area under plasma concentration versus time curve, and how to calculate the volume of distribution and the clearance using the new set of equations explained in the last lecture. Thank you.